In previous class, we discussed about the AC circuit with a pure resistance. AC circuit with a we discussed circuit are pure resistance. AC circuit with a pure resistance. Instantaneous voltage is Vm sin omega t, and current is I is equal to Im sin omega t. So Im is nothing but Vm by R. Voltage and current both are in phase, and instantaneous power equation is Vm Im by 2 minus Vm Im by 2 cos 2 omega t. Average power is V RMS into IRMS. Power average power is equal to Vm RMS into IRMS. So now waveforms, voltage and current and power waveforms. Here the power waveform is drawn in red color. So here power frequency is doubled. Now go for problem. Here an AC circuit consists of a pure resistance of 10 ohms and is connected to an AC supply of 230 volts, 50 hertz. Calculate first one current, and second one is power consumed. Third one, instantaneous voltage and current equations. Third one is equation for voltage and current. These voltage and current are instantaneous voltage and current equations. Now, the first one current, here 230 volts is RMS voltage. So if they given 230 volts is nothing but this is the RMS voltage, and pure resistance R is equal to 10 ohms. Voltage is equal to 230 volts RMS value. Now current value, RMS current value, I is equal to V by R. Here this is the RMS value only. I is equal to V by R. So voltage is 230, resistance is 10. So this we get the 230 by 10. Here the RMS current is in pure resistance circuit is 23 amps. Now power formula. So power consumed by the resistance or circuit. Now power, this power is called average power, that is equal to VRMS into IRMS. VRMS is nothing but a voltage V, and IRMS is nothing but current I. So voltage is 230 volts and current is 23. So now by calculating this voltage and current, we get the 5260 watts. Power is in watts. Now so we have to calculate instantaneous equation of voltage and current. So in general instantaneous voltage V is equal to Vm sin omega t. Instantaneous current I is equal to Im sin omega t. Here, in instantaneous equation, we have to determine the maximum voltage Vm and also maximum current Im. So here Vm maximum voltage is equal to rho 2 into Vrms. Rho 2 into Vrms. So maximum voltage Vm is equal to root 2 into voltage is 230 volts. So root 2 into 230 is nothing but 325.27 volts. So this is the maximum value of voltage or peak value of voltage. So next, current, maximum current, I maximum. So I maximum is equal to root 2 into IRMS. IRMS is nothing but I. IRMS is nothing but I. So here root 2 into 23, which gives the 32.52 amps. This is the maximum value of current. So now determine the angular frequency omega. So omega formula is 2 pi f. So 2 into pi is 3.14. Here frequency has given in the problem 50 hertz. 50 hertz is given in the problem. So now 2 into 3.14 into 50 hertz. So finally angular frequency is 314 radians per second. This is the angular frequency. Now what is the instantaneous equation? V is equal to Vm sin omega t. Here small v is equal to, that means instantaneous voltage equal to maximum voltage 325.25 into sin omega t. Omega is 314t. And current. So current I is equal to, so Im sin omega t. Here small I, it is nothing but instantaneous equation value, equation. So I is equal to 32.52 sin 314t. So finally from this problem we can calculate RMS current, calculated RMS current, power, maximum voltage, maximum current, angular frequency, instantaneous voltage equation, and instantaneous current equation. So this is, so about the pure resistance is connected to the AC supply. This is the problem for pure resistance is connected to the AC supply. So now go for, so pure inductor connected to AC supply. So L is the inductor, V is the supply, I is the current, VL is the inductor across the inductor. Now we go for problem. So we have to calculate the problem on pure inductor. So the problem based on the pure inductor. So here problem has given in this way: a pure inductive coil allows a current of 10 amps to flow from a 230 volts, comma 50 hertz supply. Fine. So first one is inductance of the coil. That means L value, determine the L value. And second one, power absorbed by the pure inductor. Power absorbed by pure inductor. Third one is equations for, that means instantaneous equation of voltage and current. Instantaneous equations of voltage and current. So from the problem we got the some points that those are, so current has given 10 amps, that is RMS obviously, and also supply voltage 230 volts has given, that is RMS voltage, and frequency also given. So first we have to determine the inductance. So we cannot directly determine the inductance L value. So first we have to determine the reactance of the inductor. So what is the reactance formula here? XL. XL means inductive reactance. Inductive reactance. XL is equal to voltage by current. XL is equal to voltage by current. So here voltage is given 230 volts and current is also given 10 amps. Now XL is equal to V by I, 230 volts by 10, that is 23 ohms. This is in ohms, it is not resistance. It is not resistance. XL is, this is the XL, inductive reactance, not resistance. XL is inductive reactance. Value is 23 ohms. In generally, some members are, so assume like this one as a resistance, but this is not a resistance, it is an inductive reactance. XL is 23 ohms is inductive reactance. Now other formula, inductive reactance is XL is equal to 2 pi FL. In terms of inductance frequency, the reactance formula is in terms of frequency and inductance is XL is equal to 2 pi FL. So we already determined XL value, frequency has given, but we have to determine the L value. That is, now L is equal to XL by 2 pi f. L is equal to XL by 2 pi f. That is equal to XL is 23 divided by 2 into pi value is 3.14 and f is frequency 50 hertz. So finally we got 0.073 henries h. H is nothing but here the inductance units henries. Now second one is power absorbed. So here the power absorbed by the inductor is pure inductor is 0. Always the power absorbed by the pure inductor is 0. So we already discussed the power consumed by the inductor is 0, but theoretically we calculated power consumed by the pure inductor is 0. So second one is power consumed or absorbed inductor power is equal to 0. Now equations for voltage and current. Equations means instantaneous equations. Voltage and current. So now the given voltage is RMS 230 volts, but we want maximum voltage. Why? The instantaneous equation of voltage V is equal to Vm sin omega t. So the given RMS, but we want V maximum value Vm. So Vm is equal to root 2 into Vrms value. That means V. Here root 2 into V maximum is equal to root 2 into 230 volts. Get the value 325.27 volts. In the similar way, I maximum is equal to, so root 2 into IRMS. Here IRMS is 10 amps. Obviously IRMS is 10 amps. So here root 2 is 1.414. So 1.414 into 10 is nothing but a 14.14 amps. Now angular frequency. So here angular frequency is omega. So omega is equal to 2 pi f. Omega is equal to 2 pi f. So f is the supply frequency 50 hertz. So omega is equal to 2 into pi value is 3.14. So 2 into 3.14 into 50 hertz, which gives 314 radians per second. That means 314 radians per second. So now instantaneous voltage equation V is equal to 325.25 sin 314t and I is equal to current, instantaneous current equation 14.14 sin 314t minus pi by 2. Why minus pi by 2 here? In current, in pure inductor, the current is always lagging by 90 degrees. So in inductor current is lagging by 90 degrees. So 90 degrees lagging means here minus pi by 2. So I is equal to 14.14 sin 140 minus pi by 2 degrees. So this is the instantaneous current equation of pure inductance. So now go for pure pure AC circuit with a pure capacitance. Here instantaneous voltage is V is equal to Vm sin omega t, that is alternating quantity, that means instantaneous voltage, and current is Im sin omega t plus pi by 2. So here plus pi by 2 is nothing but the current is leading by 90 degrees in capacitor. So this is current equation, second one. So here phasor diagram and waveform diagrams are given. Current is 90 degrees leading by the voltage behind the voltage. So here current is leading 90 degrees. The power consumed by the capacitor is 0. Capacitor circuit is 0. Here this is the equation for capacitance. Now calculate based on the capacitance problems. So here problem 4, a 318 microfarad capacitor is connected across a 230 volts supply, 50 hertz system. This means here capacitor is given C and 230 volts RMS value is given. 230 volts RMS voltage is given and frequency 50 hertz is given. So what they are asking, find the capacitor reactance. Find the capacitor reactance. Capacitor reactance means XC. Find the capacitor reactance XC. And second question is RMS value of current. RMS value of current. And third question is equations for, that means instantaneous voltage and current equations they are asking. Now in this problem we can solve as a starting point. First question, XC. What is XC here? XC is capacitor reactance. XC is capacitor reactance. So XC is nothing but a capacitive reactance. Formula is 1 by 2 pi Fc. 1 by 2 pi Fc. 1 by 2 pi F is frequency, C is capacitor value. Here frequency is 50 Hz and capacitor value is 318 microfarad. 318 microfarad. That means 318 10 to the power of minus 6 farad. Here micro is 10 to the power of minus 6. 10 to the power of minus 6. So x is equal to, so finally we got 1 by 2 pi Fc is nothing but 10 ohms. 10 ohms. Next one is current. Second, RMS value of current. RMS value of current. RMS value of current that is I. I is equal to supply voltage by reactance. So V by XC voltage is 230 volts V and XC we calculated from the first question. That is 10 ohms. XC is 10 ohms. So 230 volts by 10 ohms. It means 0 cancel. Remaining is 23. So here 23 amps. This is RMS value of current. 23 amps is RMS value of current. So now maximum voltage. Maximum voltage Vm. So in previous cases also we determined maximum voltage and maximum current. Why should required here the maximum voltage and maximum current? When we want instantaneous equations, so in instantaneous equations maximum voltage or maximum current is multiplied with the sinusoidal sin theta or sin theta. So we'll get the instantaneous equation. So for that reason we have to determine the maximum voltage or maximum current. Here Im is equal to root 2 into IRMS. The similar way voltage, maximum voltage V is equal to root 2 into V RMS. So Vm is equal to root 2 into 230 volts. That is root 2 into 230 is 325.27 volts. And Im is root 2 into I. Root 2 into I is 23 amps. So we'll get 32.53 amps. 32.53 amps. So next one is angular frequency, omega. In previous problems, we determined the angular frequency, that is omega is equal to 2 pi f. 2 pi f. F is supply frequency. Pi value is 3.14. From this, omega is equal to 2 into 3.14 into 50 hertz. So omega is equal to how much value? 314 radians per second. This is the angular frequency. Now write the instantaneous equation. Small v, that is equal to v is equal to Vm sin omega t. So v is equal to maximum voltage is 325.25 and sin omega t, sin omega is 314 radians per second. So finally v is equal to 325.25 sin 314 t. Now current I is equal to Im sin omega t plus 90. Here in capacitive circuit, pure capacitive circuit, the current is leading 90 degrees. So they written omega t plus 90. So here Im is 32.53, omega is 314 t. Substitute in instantaneous current equation. I is equal to 32.53 sin 314 t plus pi by 2. So current is 90 degrees leading. This is the problem for pure capacitive circuit. So finally what we are calculated, XC current, maximum voltage, maximum current, instantaneous voltage and instantaneous current equation and angular frequency. So these are the so very important points. From these points we can conclude one thing. So in inductor, pure inductor, that is L is denoted by L. Units are henries. So pure inductor, V by I is nothing but a XL. XL is nothing but a inductive reactance. XL is nothing but a inductive reactance. XL is units are ohms. So in terms of XL, in terms of voltage and current, is XL is equal to V by I. Now in terms of frequency and inductance is XL is equal to, that means inductive reactance, XL is equal to 2 pi FL. Here XL is equal to 2 pi FL. So 2 pi 2 into 3.14 into pi value is 3.14 and L is inductance. L is inductance. Units are, so here XL units are ohms. So here in a pure inductor, the current is lagging by 90 degrees. The current is lagging by 90 degrees. The power consumed by the inductor is 0. The power consumed by the inductor or the power absorbed by the inductor is 0. The power absorbed by the inductor is 0. In the similar way, for pure capacitance, XC is nothing but a capacitive reactance. XC is nothing but a capacitive reactance. That is V by I. In terms of voltage and current is V by I. In terms of frequency and capacitance is 1 by 2 pi Fc. 1 by 2 pi Fc. So here F is frequency and C is capacitance value. So now current is V by XC. Current is V by XC. So V is in volts, XC is in ohms, I is in amps. So maximum voltage Vm is equal to root 2 into Vrms. In the similar way, Im is equal to root 2 into Irms. So from these points, we can calculate maximum voltage or maximum current, or so that maximum voltage is also called peak value, or maximum current is also called peak value of current. That maximum current is also called peak current. That maximum voltage is also called peak value of voltage. So here angular frequency omega is equal to 2 pi f. F is frequency. Omega is equal to 2 pi f radians per second. Substituting, so this value we can get the instantaneous voltage and instantaneous current equation. Regarding in this pure inductive circuit, the current is lagging by 90 degrees in pure inductance, but in pure capacitance is 90 degrees leading. The current is 90 degrees leading. This way we can conclude pure capacitance, pure inductance. What are the equations? How can we calculate the voltage, current, XC, XL, and maximum current, maximum voltage, and angular frequency, instantaneous voltage, and instantaneous current. So somewhat just I am giving small discussion, small words, some words. So RL circuits. In this previous case, we saw pure resistor and pure inductor in different cases. Only one in resistance is connected to the supply, or one inductor, pure inductor is connected to the supply. But in this case, or else series circuits case, resistor and inductor both are combination, R and L combination. R and L are connected in series, and this series circuit is connected to the supply. So, how the voltage and current and power will vary in the circuits we can discuss later. So, this is the basic circuit of RL series circuit, and next one is RC circuit. So, how going to connect these R and C and circuits R and C is in series. So after that, so what about the voltage across the inductor, voltage across the capacitor, and total voltage how much, and current how much current is flowing, and so what are the power equations and power factor and the phase angle, how can we determine from these RL RC circuits, we can see the further classes. So now what are the different, so voltage across the resistance, voltage across the inductor, and waveforms, how can we draw the triangle, so RL triangle, and so VL VR total voltage, so how much is leading or lagging, so how the voltage will calculated, and current will calculate from these equations, so how the impedance will calculate, and phase angle will calculate, how the instantaneous power, these are all we will see in the next class. In the same way, average power also, so how to calculate the average power for the RL circuit the similar way, and RC, for the RC circuit, voltage across the resistance, voltage across the capacitor, and how the current will calculate in the RC circuit, and phase value and power factor and instantaneous power, and different types of waveforms, how can we draw the phasor diagrams also. So this is the final conclusion of in this class. So here pure capacitive, pure inductive, and pure resistance problems we solved in this case. So now